Thanks, and good morning, everyone. I'm glad you could come out this morning. I'm going to tell you the story of Earth from space. Has everybody gotten to at least take a quick look at the exhibit that's out front there? Okay. One of the reasons we want to do that book and that exhibit was that a couple years ago I noticed that there was something new and interesting going on in the world of what we call remote sensing. Remote sensing is just a fancy word for looking at things from a distance. But in the context of understanding the surface of the Earth, what we mean by that is taking pictures from airplanes or satellites. But what we wanted to show people was the combination of technical prowess that was necessary to collect these images, but also some of the aesthetic beauty of the images. Because a lot of these pictures that are recorded by satellites can be appreciated both ways. Obviously, nobody launches a satellite. Satellites are very expensive, right? Nobody launches a satellite just to take pretty pictures. They're useful for scientific or technical purposes. But we can take those images and we can appreciate them because they're beautiful pictures as well. So in this talk this morning, I'm going to go through a few different themes that you often see when you're looking at images from space. And some of these themes are reflected in the exhibit that you see out front, although the way I've structured this more closely follows the book. So let me just launch right in. First, the global view. Well, the whole point of using these images from space is that we can do a few different things. We can look at the entire Earth all at once, or we can zoom in to see little tiny details. Some satellites are good at seeing the small details. Other satellites are good at looking at the whole planet all at once. And I'll go through a few of those differences here. But just to give you an idea of the difference of scale, we can look at the whole planet, or we can zoom in to sort of continental-sized areas. This is the kind of scale that we observe the surface of the Earth with satellites like Landsat and Spot. Or we can zoom in and see more details. Now we're starting to see individual buildings. There's a whole new generation of commercial satellites that provide imagery with that kind of detail. Down to, here's the US Capitol building in Washington, D.C. This is about the limit of the level of detail we can see with non-military, non-classified satellites. So you've got tour buses waiting to go into the US Capitol building there, and so forth. Now, these are the kind, when we first did the book a couple years ago, people were not used to seeing this. But of course, nowadays, people are used to seeing images like this. And here's downtown Kingsport just from Google Earth, which we're living in a time now, the last sort of year to 2 to 3 years, where people are getting more used to seeing these images because they're available on the internet. And that's one of the things that's made all these things possible. There's a few different kinds of technology that make remote sensing possible, to make these pretty pictures possible. First of all, you need aerospace technology. You need to be able to build satellites and launch them on rockets. Now, it sounds like a pretty complicated thing, but it was actually the first kind of technology that we got figured out. Second kind of technology, sensor technology. How do we actually record images? Everybody has if you have a camera these days, does it actually use film anymore? Now, I have to explain to children. Now, cameras had, even the kids probably know this, they had film and you had to process it. Whereas now it's all digital. Well, the same kind of thing happened in the world of remote sensing, but it happened earlier than when it happened in consumer electronics, of course. So that all the images I'm showing you this morning, all of them that I'm going to be showing you here are all digital. But in the past, there actually have been satellites that have used film cameras. They would actually roll the film up. I'm going to show you one of those images, and it would re-enter the Earth's atmosphere, and they'd capture it and develop the film. Then the third kind of technology is information technology. If these images are digital, how do you store all this data, and how do you distribute it out to people? Well, it's that internet access that's really revolutionizing where people are the kinds of images people are used to seeing. So let's talk about some of the technology that we're seeing here. There's an image of St. John's, Antigua, in the Caribbean. Here's a rogues gallery, if you will, of different remote sensing satellites. The one on the upper left there is a GOES satellite. That's a satellite in what we call geostationary orbit. It goes around the Earth once every 24 hours, and it records images of an entire hemisphere of the Earth. Now, the reason you want that is that the satellite stays stationary, or at least it seems to stay stationary, if you're standing on the Earth. So you can just take pictures every half an hour or every hour. Now, where do you see images from this satellite every day if you watch TV? Anybody know? The weather, yes. When the guy is telling you on the weather, on the TV news, if it's going to snow the next day, and then there's a picture behind him showing a front, coming through that's going to make your weather miserable or not, it's images from that satellite. They're in a very distant orbit, thousands of miles above the surface of the Earth. And like I said, it goes once around the Earth. It goes around the Earth the same time, the same speed that the Earth rotates. In the middle top is the Landsat 7 satellite. The Landsat series of satellites are our longest serving series of satellites that do land remote sensing. They show us images of the surface, of the land surface. First Landsat satellite, which is not up here because it's not working anymore, was Landsat 1. It was launched in 1972. Landsat 7 is still up there and working. However, there's a few things about it that have broken. The details aren't really important here. But the next Landsat satellite, we might actually have a gap in the coverage. So you can actually ask Ron Beck about that next week. He'll tell you all, because he works at USGS Aeros Data Center in Sioux Falls, South Dakota, and they are the people that actually operate this satellite. Then we've got, let me see, a NOAA satellite in the middle left. Landsat 5 is there in the center. SPOT is this one right here. That is another satellite that observes the surface of the Earth at the same kind of scale as Landsat, but it's a European satellite. On the bottom is Terra and Aqua. Those are two large NASA satellites that do environmental remote sensing. We're learning a lot about how the planet operates using those satellites. On the right side of the screen are three satellites called Iconos, then there's QuickBird, and then there's OrbView 2. Those are all satellites that have been launched by commercial companies. One of the new things that's happening in the world of remote sensing is that there are corporations that actually launch satellites to collect images, and their goal, of course, is to make money selling the images. These days, the market for that kind of imagery is sort of settling out. One of the companies bought another one. But the point is to use these kinds of images instead of photographs taken from airplanes. I just threw this up to remind me to tell you that one of the things we're doing with this kind of remote sensing is we're starting to understand the Earth almost as a machine or as a complex interconnected system, right? A system of systems. So what we can do is we can make, on a regular basis, maybe monthly, we can make global maps of different things about the Earth. So the one on the upper left shows sea surface temperature. The temperature of seawater is something that's easy to detect, relatively easy to detect from satellites. And the temperature of the seawater tells you all kinds of things about how energy is moving between the ocean and the atmosphere and things like that. The middle left one shows a cloud cover. The brighter the area, the more cloud cover there is there. And cloud cover plays an important role for how much energy is absorbed into the Earth versus how much sunlight is reflected. If you have bright clouds, it reflects that sunlight away. Just to pick a few others, the top left one is atmospheric aerosols. So those are microscopic particles that are floating in the air. And again, they interact with sunlight in specific ways. Some kinds of aerosols absorb sunlight, other kinds of aerosols reflect. It turns out you can also tell the difference between aerosols from things like fires or volcanic activity and from human activity, because they actually interact with sunlight differently. So just to give you the idea that we now live in an era where we can actually make these maps on a regular basis, and then scientists can use these maps to help understand how matter and energy and gases and so forth move between the land surface and the oceans and the atmosphere as a cycle. Okay, little bit of background now. On the top there, we got a little diagram. There's the Earth in the center. I know it's a little bit fuzzy there, but you see, I mentioned the geostationary orbit. That's that ring. It looks like a ring around Saturn. That's where that weather satellite operates. But there's the little line almost, it seems like it's touching the planet. That's where most of our remote sensing satellites operate, much lower. They're hundreds of miles above our heads, not thousands. They orbit at a higher altitude than, say, the space shuttle. Okay, maybe twice as high. But they're not thousands of miles out there. Now, I need to review a little bit of high school physics here. Here's the electromagnetic spectrum. As you're aware, what we see with our eyeballs is just a few wavelengths of light. But there are other wavelengths of light that we don't see with our eyeballs. But we can build our machines to use those wavelengths of light. Specifically, you're going to hear me say a lot about infrared light. Infrared light is emitted by the sun, and then it reflects off the surface of the Earth, and we can detect it, and we can make pictures out of it. And there's a lot of important reasons for doing that. Ultraviolet light is not as useful for the kinds of remote sensing I'm talking about today because the atmosphere blocks most of it. Although if you're interested in studying the atmosphere, you can use ultraviolet light.